do is we'll begin with this idea that we learned last class about certain relationships. Specifically, we have central angles and inscribed angles. And what we got was this idea that if we have central angle, come on, focus on me. There we go. We learned that if we have a central angle, this arc is the same size as this. And we learned that when we pull it back all the way to the edge of the circle, it becomes 1/2 as much. But in your Great Circle Challenge, you had some occasions where they met somewhere else in the circle, right? They weren't at the center of the circle, and they weren't on the wall of the circle, and you didn't have a rule for that. So today, we're going to prove what that relationship is. I'm going to call this arc measure A, and this arc measure B. They're different values because I want to come up with a solution that, that works for everything. So I'm using two different variables here. I'll call this angle X. Now I'm going to connect these endpoints, and I'm going to connect these endpoints. I've now produced triangles. And because I need to get these involved, I'm going to put in, say, W and Z as these other two arcs. Again, just using variables so that I'm not biasing this problem to be, oh, it only works if it's a right angle or something. Can you tell me what the measure of this inscribed angle is? This is refreshing what we learned last class. If I look at that angle, it's like a flashlight shining on this wall. So how big is that angle? 1/2 of W, right? And what about this angle? Good, 1/2 of Z. Okay, I now have a triangle with these three angles. And we know that any triangle, the three angles add up to how much? Good. So X plus 1/W plus 1 over, excuse me, not 1/W, 1/2 W. Plus 1/2 Z equals 180 because it's a triangle. And I'm not a huge fan of working with fractions. They tend to make things more difficult than they need to. So I'm going to multiply everything through by 2, giving me 2x plus a full W plus a full Z equals 360. Now, you guys are following me into a deep, dark forest. You have no idea where I'm headed, but do you agree with what I've done so far? Nothing magical here, right? This is all valid stuff. Now, the outside of this circle has 4 different arc measurements. And if I were to add all 4 of those together, what would those equal? 360. So I'm going to say A plus B plus Z plus W equals 360. I've now got 2 expressions, 2 equations, both of them equaling 360. So I'm going to set them equal to each other. I'm going to say that this part is going to equal this part because they're both equal to 360. It's a form of substitution to solve. And now I can see that I've got a W on this side and a W on this side and a Z on this side and a Z on this side. And so when I subtract those, I get 2x equals A plus B, or to solve for just x, I get 1/2 of A plus B. But what does that mean for us? Well, It means that if I have two chords crossing inside a circle, and this arc is 140, and say this arc is 60 degrees, and I'm looking for that angle, I can say that x equals 1/2 the sum of these. So x is 100. What's another word to describe when you take the sum and divide by 2? If you've taken two tests, you got 100% on one and a 92 on the other, and you add them together and divide by 2, what do you call that? The average. So in other words, when we looked at this central angle, it's the full arc size. When we look at the inscribed angle, it's half the arc size. And when it's somewhere in between, it's somewhere in between. It's the average of A and B. So let's put that into our notes. We're going to be talking about several different types of intersections inside, on, and outside the circle. This first one is here, the interior intersections. So if I want to find the measure of angle 1, I recognize that the point which satisfies their vertex is somewhere in the middle here. So it's going to be the average of these two arcs. So 1/2 of the measure of arc AD plus the measure of arc BC. Can you please try to fill in measure of angle 2? What should that say? Can I get a volunteer to share with me what the other half of the equation for angle 2 would be? Nick?
Measure angle 2 equals 1/2 parentheses measure angle AB for arc AB.
Good.
Plus measure of arc BC.
Very good. And I love the way you're using the terminology. You're describing that it's the measure of the arc. Really good. Perfect. Any questions on what the rules say? Okay. Let's do a couple of examples. Number 1 is super straightforward. It asks for AED. You can see that little yellow angle there, and it is facing both of these angles. So my formula is just going to be straightforward. I'm going to take the sum of these two arcs and multiply it by 1/2. So the sum of the arcs is 154 times 1/2 is 77 degrees. Would you please do number 2 now? Same style. Hey, I got 149. Anyone get the same answer? Okay, good. How's it feel so far? 5, I think I can do this. This seems really doable. 3, I think if I have the notes handy, I can do this. 1, this is going to throw me. Excellent. Now, you know that things can't be as easy as they are the first time through, so we're going to see a little bit of challenge here. Let's look at number 3. Now it's asking for YWX. Problem is the two arcs that work with that angle, I don't have any information on. So how could I find this? Hillary? Very good. If we find this orange one first, because we've got the two arcs we need, we can see that the orange and the yellow form a linear pair. So I'm going to find the orange one first. It's going to be 1/2 of 43 plus 81, which is 1/2 of 124, which is 62. Then to find the yellow one, which is what we're looking for, measure angle YWX, is 180 minus 62, which is 118. What about 4? How did they twist it on 4 to make it more challenging? Good. So you'll notice that in all these things, I only had half of an equation. Really, that's not good quality math. What I really should have had was that the angle equals that. So I'm going to come over here and I'm actually going to write angle equals 1/2 of arc plus arc. And that way, when I come over here, I can read that because this time I've got the angle. So that part's going to be isolated on the left. And I've got one of the arcs. What should I put for the other arc? X. We don't know what that is. And so now I have to solve this. There's a couple ways we could go about it. One way would be to distribute that 1/2, but then you get 1/2 of an X, and that just seems unnecessarily challenging. So what's the easier way?
Well, the average of 74 next to 62. 62 is 12 less than 74, so you can just subtract 12 from 62.
Interesting. You guys catch that? That's clever. That's good mental math. He said, just in my head, I get the idea that 74 and something else are averaging to 62. So however much 74 is too high, I need to find the number that's that same amount too low. So the difference of 12 subtracted would give you 50. I think I was looking for a very simple algebra solution, but I like your creative solution. Multiply everything by 2. That'll clear out our fraction here. So we'll get 124 equals, that cancels there, 74 plus X. And if I minus 74, I confirm Nick's intuition that 50 is equal to X. I guess it isn't intuition, is it? It's just a different form of reasoning. All right, let's have you guys try 5 and 6, please. They're going to ask you to think about them a different way. Go for it. Feel free to talk and engage. And those of you on Zoom, what I'm going to do is I'm going to put the audio off for a second so that if you guys want to talk and engage, you can. It'll be as though you're in a breakout room, but you don't have to go somewhere else. If I were to connect two chords meeting on the circle, that would just be an inscribed angle that we've already done. So we're looking for something new. And what we're going to do is we're going to talk about a tangent line meeting a chord. And you remember that a tangent only has one point of intersection or one point of tangency. And we're going to try to figure out how this little angle relates to the arcs in this circle. And I know this throws people because the angle we're talking about is kind of outside of the circle. But I'd like to pose the idea here. Let's say that, for example, I took the endpoints of this chord and I connected them to make an inscribed angle. If this arc is X, how big is this angle? 1/2 X. And even if I moved it over to here, how big is that angle? Still 1/2 X, right? And if I moved it over even closer, wouldn't it still be 1/2 X? So I want you to visualize now that I'm shrinky dinking you way, way down. So you're now like walking along this circle. Okay. And as you walk along, you see that point. That's that little point there. Oops. And you see the very, very next point right next to it. And do you agree that if in fact we were to bring an angle to this point and then plop it right next door, that would still be 1/2 X? Even if it was only 1 point distance for this part of the angle. But the question is, what happens when I bring that in and go directly to this point? I don't have a second leg for my angle, do I? But it turns out that the tangent line can come in and it will produce this angle that will be exactly the same as this angle. You like bring in a pinch leg of the angle. So it turns out I call this the extreme inscribed angle. If this arc is X, then this angle here is 1/2 X. And if this arc is Y, then this part, this angle is 1/2 Y. It's kind of hard to see because there's so much imagery on there. So if I've got a tangent and a chord, this, if this is X, this is 1/2 X. And if this is Y, this is 1/2 Y. It's just an inscribed angle. It's just pushed all the way to the end. And what's the sum of X and Y? 360, which makes sense. It's all the way around. And what's the sum of 1/2 X and 1/2 Y? And doesn't that make sense too? All right, so here's where we're going with this. Given this picture, we're going to say that angle 1 is equal to 1/2 of the arc that it meets. And notice that comes from the point of tangency, A, up to the end of that angle. And what about angle 2? What would that equal? It's got to be a major arc, doesn't it? So we'd say ACB. So looking at number 7 here, DEG. Okay, that's a nice straightforward one. This is my angle, and this arc is given to me. So the measure of angle DEG is just 1/2 of 308. which is 154. And let's do number 9 together. There's a little trick here because it's asking about that part. So there's 2 ways we can do this. Can you think of one way? Okay, yeah, you were getting at that though. Good. Same idea here. Well, except this 151 is the angle, not the arc now. Good. That would do one way, right? If we multiply 151 times 2, we get 302, and that's the arc, which means xy would be 360 minus 302 is 58. There is an alternative way to do it. We know this straight line adds up to 180. So couldn't we say 180 minus 152 leaves us with 28? And if that's the angle, then the measure of the arc would be twice 28, which should be 56. Oh, I wrote 152, it's 151. 29 times 2, which is 58. Sorry, that got sloppy. All right, please do number 8 and 10. Yes. It's 29 because I did 180 minus 152 when it was really minus 151.
You're doing 8 and 10?
Yes, please finish the 2 in this section. The third piece comes from the idea that if I have an arc on the inside, I don't want a central angle. That's the same measure. I don't want average between them. I don't want half as much. I want to pull that angle out even further from a central to an average to half. If I pull it all the way outside of the circle, what happens? Ooh, clever. You think this will get bigger? Smaller even than half as much, right? Like 1/4, that's a reasonable guess. Let's see what happens. So what I'm going to do is I'm going to draw from the bottom part of this arc to the top part of this arc and create a chord. And how big is this angle right here? Good. If this is A, then that's an inscribed angle, so it's 1/2 A. And I'd like to get this angle as well, because then I'd have all 3 angles in a triangle. So how big is this angle over here? Half of B, right? But I don't really want that angle. I want this one over here. I'm going to redraw this a little bit. So I've got X here. I've got 1/2 A here. And I'm trying to find this angle. So far, I've only got 1/2 B. What's this angle? Really good. 180 minus 1/2 B. And now these 3 angles together add up to how much? 180, right? Because it's a triangle. So I'd say X plus 1/2 A plus 180 minus 1/2 B. And all of that should equal a triangle, or 180. Well, I've got 180 on both sides. So that means X plus 1/2 A minus 1/2 B equals 0. Well, I'm trying to solve for X. So let's get X all by itself. We'll subtract 1/2 A and add 1/2 B, and I'll get X equals 1/2 B minus 1/2 A. So x equals 1/2 of B minus A. In other words, if I've got these, and this is like 100 degrees, and this is like 20 degrees, I'm going to find x by saying, I'm going to take half of, not their sum, but of their difference. So I'd take the big arc minus the little arc and take half of that. So it'd be 40 degrees. It's not going to turn out to be 1/4. It's not going to turn out to be 1/8 or 1/3 or anything like that, because it'll change. The minute I adjust this one, this angle will change as well. So it's got to take into account both of those. So that's the first one of this style. The second one is, what if in addition to this secant over here, I bring a tangent into the game? Well, it turns out we can do this exactly the same way. So if this is like 150 now, and this is like 30, we can still just say that x equals 1/2 of the bigger arc minus the smaller arc. Pretty reasonable, right? Last one. What if these are both drawn better than mine? Tangent lines. I could do the same thing, couldn't I? I could take the big arc minus the little arc and divide by 2 to find this. But watch what's going to happen here. I'm only going to give you one of the arcs. Are we flummoxed? Excellent. Because these are tangents, there's no part of the circle that's being lopped off. So this 100 and the rest of the arc all together make up 360. So I can subtract that and make a conclusion that this part is 260, and then use my regular formula. X equals 1/2 of the big one minus the little one. Easy enough. But can you make it even easier, Mr. Erlin? Well, yes, in fact, I can. So watch this. I'm going to pull this up a little bit, create another version over here with 2 tangents. And this time I'm going to say it's 30 degrees. So we would do the same process. 360 minus 30 degrees is 330. And then to find x, I'm going to take 1/2 of 330 minus 30. 1/2 of 300 is 150. Now, what I want you to look at is the answer I got here, 150, and the original arc, 30. And the other problem, we had an answer of 80, and the original arc is 100. Can you notice any pattern? Someone said it. They add to 180. Wouldn't that be lovely if that were the rule? Right? Like if this were 70, we'd know right away that this just has to be 110 because they add to 180. Well, I've now seen 2 examples of it. Is that enough for us to claim it's definitely always true? No? How many examples should I have? Like 4? Like 6? A million? Remember way back, like day 1, 2, 3 of geometry for us? I did the bridges of Kronsberg, and I had you learn about like tracing. Remember that? and you were trying to figure out whether you could make certain shapes or not. And then we talked about nodes, even nodes and odd nodes. And we tried to come up with an idea about the rule of when a figure is traversable. And you had a certain set of data, and you all came up with a good rule that worked for that data. And then I gave you more data, other examples. And for some of you, that broke your rule. And so we adjusted our rule, and you came up with, you're like, I think this is always true. But again, I could give you some strategically selected problems that broke those rules. This was intended to give you a vision of inductive reasoning versus deductive reasoning. Inductive is when you take a pattern and you say, okay, it worked here, therefore I project it always works. Deductive is where we prove that fact. It's much more sound logically. Let's see if we can do it here. So what we're saying is if this is X and then somebody gives us A, we want to be able to find the value of X without figuring out this part over here. But if we did figure this part over here, how much would it be? If this is A, this is good, 360 minus A. And then I could say that X is equal to 1/2 of 360 minus A, the big arc, minus A, the little arc. Just clean that up a little bit. 360 minus A is like minus 2A. And if I distribute that 1/2 through, I get 180 minus A. Or I could add that back and say that X plus A have to equal 180. In other words, now it's proven. X and A will always equal 180. If it's this situation, starts with two tangents. So let's add these rules back into here. The first one is when there are two secants, and I'm going to say the measure A is equal to 1/2 the measure of arc CE, the bigger one, minus the measure of arc BD. This second one is the same idea exactly. It's 1/2 the bigger arc, measure of BD, minus the littler arc, measure of BC. And this last one is the specialty case. Even though it satisfies these as well, what we're saying is that measure of angle A equals 180 minus measure of BC or it turns out, and I didn't show you this one as well, the measure of A could also equal the major arc, BDC minus 180. And I'm going to suggest for these that we add in a little word version over here to help you with the more unraveled ones. That the angle equals 1/2 big arc minus small arc. Doesn't fit very well, sorry about that. So let's do number 11, please. Big arc minus small arc times 1/2. So the angle is 1/2 the difference of the arcs. So 1/2 of 74, which is 37 degrees. And then I think we've given you some practice in how to do these kinds of things if a different piece is given as a gap, right? Like, what if the angle is missing? What if the arc is missing? What if the arc is not given to you, but it's part of a semicircle, so you can find that piece? The rest of class, I'd like you to finish this packet, pages 1, 2, and 3. Ignore page 4. We'll do that a different day.
Sarah?
Yep. Yes.